my group members and I will be demonstrating our lab practical with title UV visible spectrophotometer. So our objective today is to demonstrate the principle of the UV-Vis spectrophotometer as well as its application. Before starting our experiment, I will be showing the apparatus and materials needed for this experiment. So starting with material, we'll be using potassium permanganate and then some of the distilled water to dilute it to make different concentration of the KMnO4, and then the other thing I'll be using is the cuvette. This cuvette is made up of quartz, which is expensive, so we should handle it with care and make sure wear gloves to prevent any fingerprint marks on it. And next we'll be using measuring 10 ml of measuring cylinder and also 10 ml of 100 ml of volumetric flask. And we will be using also micropipette. And the machine we'll be using today is UV-Vis spectrophotometer. And this machine, we are using this machine to measure the different absorbance of different concentrations of the KMnO4, which is our sample today.
Hello, I'm Mirza and we are preparing the stock solution for the KMnO4. So, we should take 0.126 grams of KMnO4. And now we are adding the KMnO4 into the volumetric flask. And now we are going to top up. Okay, since we already prepared the stock solution, now we're going to prepare this standard solution. These here are the 4 standard solutions that we need to prepare. First, take 1 ml of the stock solution, which is this. Okay, 1 ml, and top up to 10 ml of distilled water. Secondly, this is for the serial dilution. Take 5 ml of your previous standard solution and top up to 10 ml of distilled water. And then for the third standard solution, take the second standard solution. Take 4 ml of the second standard solution and top up to 10 ml. And finally, take your third standard solution, 5 ml of it, and top up to 10 ml of distilled water.
Hello, my name is Pavitira and now I'm going to run the sample. First of all, we need to put the wavelength scan at the range of 420 nanometer to 600 nanometer. So we're going to set it within the range. And now we have to first of all put the blank and make it to 0. We must ensure it's a clear part at the both sides. Okay, now we have 0 the blank, and now we have to put our sample at the blank place. Now we'll be putting the sample inside the and press it. This is the absorption spectrum for the sample.
Hi, I'm Vidashini. Okay,
Okay, so I will be explaining about the spectrum graph. Okay, as you can see here, there are many peaks. So you have to find the maximum wavelength based on the graph. So what you must do is press option, view the table, then you go down, find for the peak. As you can see here, they got 2 peaks, so we have to choose the lowest one as to standardize it. Okay, as you can see here, we must choose the lowest peak. The absorbance value is 1.855, which is correspond to 545 nanometer of wavelength. Okay, as a conclusion, the purpose of running the samples through the range of wavelength 420 to 600 nanometer is to determine the maximum wavelength.
Okay, hi, I'm Sandrika. I'll be explaining about the calibration curve. Okay, since the maximum wavelength has been set to 545 nanometer, now we will use samples of different concentration. Before that, we have to use the blank to reset the absorbance to 0. So you'll be wiping off the fingerprint, set it at 10. Okay, now I'll be going to single wavelength and I will make it to 0. There, that's 0. Now I'll be running through the sample. Repeat back the same thing. Remove the fingerprint. Okay. Close and I will read it back. So this is the absorbance value for the concentration at 545 nanometer. As now you can see, this is the absorbance value obtained for the sample of concentration 0.0008 molar. The same step will be repeated for the samples with other concentrations. Okay, this is the results obtained for the concentration of sample. Once you get the absorbance value, you need to jot it down under the absorbance pipe. As you can see, this is the graph plotted. On the x-axis, it will be concentration of the sample, whereas on the y-axis will be the absorbance value.